Assignment 2. Man, it is a fat spec. Let me just simplify my life a little bit here. The late submission policy is the same. The submission rules are the same. The dry run's the same. The rules around originality are the same. Git commit requirements are the same. The only difference I've told you with the git commit requirements is I have done that thing now where Git won't let you commit if you break the rules, which is good because like I noticed that 90% of students last time were like, oh my God, I know the thing, but I just wasn't paying attention. Just like in the zone, you know, solving a problem. And then they push it and then they're like, oh, Hayden's gonna give me 0 now. And then they're panicking and I'm getting emails and stuff. So hopefully that de-stresses everyone a lot. The criteria is the same, though we did add a 5th one here around simplicity, which is basically encouraging you to not write tests that themselves look like they need tests to be written for them. Because that came up on the forum a few times. So that's section 3. And then if we scroll all the way to the top, section 1 is an overview about this particular class. And then section 2 is the task. So we should hopefully be able to talk about this in 15 minutes. This assignment was inspired by a guy called Gary. Gary works at Google. Nice bit of alliteration there. And thought it was a cool idea. So this assignment was written sometime in 2022. Gary, I can't remember if Gary or another couple of people did a lot of the heavy lifting. I got taken off this course for a while around the time that they started writing this, so it's exciting for me to see it come to life. So compared to the other 2 assignments in the course, I've never actually done this one myself, so I'll still do my best to give the best answers. I understand it though. I've had to read the spec and for like a few hours and I get what it's asking. It's not the hardest thing in the world, but the concept, it's called a filtered string view. A string view can be thought of as a view into an existing character buffer. And what that means is like you have a character array or something, think C-style character array, and you can create a string view into it that is essentially like a pointer to a part of that character array up to a certain length. So if I have a big string that's like watermelon, I could create a string view that just points to the M and is just like able to see the melon part of it. So it's a view into a part of a string. It identifies a section of the string and cannot be modified. Cannot be modified by the view. So you can't use it to change stuff. What's the point? This section isn't relevant to the blah, blah, blah. When creating a function to take a constant string as an argument, programmers often opt for one of the following, which is they either use C-style pointers or they use C++ style references. These work fine when the caller has the string in the format already provided, but what happens when a conversion is needed, either from a const char star to standard string or standard string to char star, is that people need to find a way to convert these things. So in this case, it's like if you already had a string, you have a function that then if you need it in like a char star form, we're going to get a little into pointers here, you need to actually convert it to a C string. And that is sometimes bad because it can create memory. Like it uses memory, right? This is really finicky stuff. Like this is the idea of a string view function or library is really like a super fundamental type. So when we think about, oh my God, we might be making like 5 bytes of unnecessary memory along the way. Like, yeah, but the premise of this from Gary at Google is that if you're working on these large scale systems being called, billions of times on like strings, then unnecessary copies have a really big impact. So we want to create something instead which is a string view. And a string view has implicit conversion constructors from both const char star and reference to const standard string. And since string view doesn't copy, there is no memory penalty for making a hidden copy. Now, if this doesn't quite make sense, I wouldn't worry too much, because the first time I read this, I was like, what the fuck did you do, Gary? That was my feeling. And then I kept reading. So what we're going to be doing in this assignment is we're going to be creating a version of the string view called a filtered string view. So a filtered string view represents a filter of the underlying data. That means the readers may only see part of the underlying data, like the example I gave with the watermelon. The filter is optionally provided by the caller, which is fine, blah, blah, blah. Some of this will make more sense later. Required internal representation. So you're making a class. You're creating a class for assignment 2, and what we're requiring you to do is, because it's not intended to own underlying data it's pointing to, it's sufficient to represent the data by using a single const char star and a size t. So basically, all your class will store is a size t for the size of the, string, and a pointer to part of that string, or the string, whatever. Yes, we're letting you use pointers. It's the only pointer you can use in the assignment. Well, it's more than that, but you kind of get the point. I'll come back to the predicates, and it's intended to be lightweight and cheap to copy, because if you copy it, you're not duplicating the string, right? Because it's just a pointer to a string. So every copy, even if the string's 100 kilobytes, you're just copying a pointer and a size t, right? Small, copy. Constructors always refer to the filtered data, etc. Now, we'll come back to the filtering part. The predicate things are a little bit slightly confusing. But the way that this entire spec works is we basically just give you a whole bunch of things to define. It's a breadth assignment. It's not like word ladder. There's a bunch of tiny functions. We want you to create a default constructor, right? We tell you what to do. Constructs a filtered string view with a pointer set to null pointer and a length set to 0, and the predicate set to the true predicate. Okay, you probably got to store that too. I'll come back to the predicate. And there's an example of default constructing. You're shaking your head. You're like, I love it. Keep it energized. I think it's that time of night where we're close enough to the end that I'm going to wake you all up again. Yeah, it's like on a when you fly internationally. Has anyone not flown internationally? They're just like 2 hours before landing. They're just like, lights on. We're all waking up now. Cool. Implicit string constructor. So they're saying, well, you should be able to get past a string when it's being constructed. Constructs it with a pointer set to the string's underlying data and the predicate set to true. Hint: you can obtain the underlying data by calling that. Constructor should not be explicit because it's actually desirable. Like, it's quite methodical. Like I'll keep going through this, but it's really quite laid out. It's a finicky assignment. You're going to fight the compiler mostly. If it runs, you're going to be like, I'm basically done. Yeah.
Are you meant to be orders?
Vaguely. I mean, I don't think there's a requirement, but it's sure as shit hard to do some stuff without a constructor, for instance. If something's hard and you're like, this looks skippable, yeah, skip it. It should be fine. String constructor with a predicate, predicate. Implicit null terminated string constructor constructs a filtered string view with the pointer set to the given null terminated string. When they say null terminated, they're just trying to remind you that there is like a null point in it, because some strings might not. Copy and move constructors. We talk about copy and moving next week. I don't think this would really stop too many people right now, particularly the copy constructor, but the move constructor we talk about in week 5. So the move constructor part might be hard, but the copy constructor part's fairly straightforward because you're just copying some stuff across. It has to be equal, blah, blah. The underlying character buffer should not be deep copied. Yes, because you have a pointer to it. We have our destructors. Sure. You must explicitly declare the destructor as default. This is another great example. This spec is literally telling you to write that line and then write that it equals default, right? Not delete. Default, and then put a semicolon. And that's like a tick for that part there. So that's like all the setup and destruction. Then we have like member operators. So you should be able to copy assign. It's basically like the copy construction. Move assign, we talk about that next week. You should be able to subscript things. You should be able to type convert stuff. So if someone tries to static cast a string to your object, to a string, wrong way, sorry, enables casting. So if someone takes your filtered string view and tries to static cast it to a string, it copies the filtered string to to the new string. You know what I mean? So it's like if someone's like, I want a copy of your filter, you actually just be like, oh, time to manifest myself into a real string. Member functions, you got your ats, like a vector. You've got your size, makes sense. You've got empty. It's not,
Just go through every single function it requires.
Yeah, man. We got a long way to go. No, I don't know. We've got a little bit to go. Data will return a pointer to it. Yep.
No, I don't mean like this thing that the specs. Like
Yes.
any function you create that's not
No, if it is not written down, it is not your problem in terms of functions and stuff. Predicate, I said I'd come back to that. Non-member operators, these are your friends, right? Equals equals, makes sense. Relational, makes sense. This operator we didn't cover much. That's a bit of a bonus one. It's called the spaceship operator. It's new as of C++20, should work fine. That one's kind of your like open-ended, do a bit of research online. It's fairly straightforward to find. It's meant to make this stuff a lot easier. Basically, if you define this weirder operator, it's like a shortcut way to define all of these. But if you want to, I don't think the compiler can really tell between these ones and that one strictly, not like our auto marking. Like our auto marking just checks if A is less than B. So if you want, start off with these ones, which you might feel more comfortable with, and then come back to that later, because that's probably just your tutor noting something when they mark it. Output streams, okay, it needs to be outputted. Non-member utilities, there's one here called compose. That one looks a bit more involved. And split, these are kind of the more interesting functions, substring and stuff. These ones are kind of where you actually get to stop and have a bit of fun, because by the point of defining .empty, .size, you're probably like losing your mind a little bit. But after those few fun functions, we get to iterator. Now this should be quite fresh in your mind, because we've just talked about it. You must define an iterator for this class. Conceptually, the iterator, blah, blah, blah. You need to implement only a bidirectional const iterator. So you don't even need to do the non-const iterator, just the const iterator. What do I mean by that? Well, if you go back to our previous code like this, it means that you don't need to do these ones here. You only need to do the const ones. And it's bidirectional, so you'll also need to do the reverse const ones as well, but not the non-const ones. It's kind of a useful part of the assignment because you can't modify anything, which is great. Yep, here's some sample code using the iterator. SV here refers to your filtered string view. So, we're basically just saying that you should be able to, this is a great little example. It's like, I know it's written like a lambda, which might make it a little bit inaccessible to some, but where's it? Yeah, here it's just saying you should be able to take your string views, start and end operator, iterator, and basically copy it into an output stream. So print it to the terminal if you want to. And you can play around with it. You should be able to loop through it just with a basic for loop and stuff as well. Cool. Yep, C begin. I mean, just to be clear, the way the spec's written is a little bit weird because I didn't write the original spec, but I did clean it up a little bit when I had a look at it this time. 2.9 asked you to implement the iterator, but then 2.10 asked you to do the range, which is referring to like these things here, the C begins, C ends. You kind of need to do the ranges to get these examples working. So like think of 2.9 and 2.10 as like one thing to do. Don't be like, oh, I need to finish that and then go and implement the .begin and .end, because you kind of need the .begin and .end to make the iterator work, because otherwise you can't access it. Const correctness, anything that should be marked as const, mark it as const. That one's just a little gotcha to see who's paying attention, because like you can define functions and write tests without doing const versions without realizing, and then your code breaks down. So we talked about that back in 3.1 as like any member function in a class that doesn't need to modify anything should be marked as const. Exceptions we also talk about next week, but honestly, there's not going to be a lot in this assignment in terms of exceptions. We basically just ask you to mark functions as no except. We talk about that next week. Remember, this is due in week 7. It's a long time away still. So it's next week's exceptions and resource management, which is to do with has a little bit of move and stuff in it. Performance, there's no real performance in this one. if you think about what you're defining, there's nothing that should really take a while. I don't want to say, like, people always ask me, what's the time limit for this? I'm like, bro, if your code takes more than a second to run the test, you've got real problems, right? So there's only two types of people. Code that finishes in like milliseconds or a few seconds if you did something crazy, and then someone who put a while true in their code and it never finishes. And then the auto marker will kill it at some point because it's like, you're wasting my time. So short of putting while trues in there, don't even worry about performance. A lot of you will want to because you just came out of word ladder where you're staring at that benchmark being like, yes, 12 seconds, right? But none of that. Forget that, move on from your life to other things. A few other notes down here, and that's kind of the end of it. I said I'd talk about the predicate as well, because that was the one thing I glossed over a lot. Where is that little thing hiding? Yay, string constructor with predicate. Now, predicate, you can see, has a type filter. Where has that been defined for us here? There we go. There is a type here that's defined, filtered string view default predicate. Let me just check the code out. Might be easier if I can. Yeah. Member type defs go here. So this is the code we give you. We kind of put the iterator there. We put a few of the functions there for you. Not everything naturally, but we put some of the things there. You will do a lot of your implementation here because we want to keep your implementation separate from the .h file in general. And then we've kind of got our tests here. But yeah, so do a fair bit of implementation in that CPP file. Yeah, so what you'll see here, this is where I was looking for it, is that a filter is the type of the predicate, is a defined as a standard function in C++ that, my brain, returns a bool and takes in a reference to a const character. So it's a string view. So it's a view over a string is characters. So what a predicate is, think about it like are you familiar with lambdas? Remember lambdas from week 2? You might have learned lambdas from another course. JavaScript, it's anonymous functions, just passed in. Is it saying that there's a function that someone could write, there's a type that's a function that takes in a reference to a character, and that function returns true or false. It's a filter because you give it a string, this filter's applied to every character, and it says, yep, true, true, false, true. It's simply a function, tells you whether a character's in that string or not. So when we get down to the constructors and stuff here, like this one, someone says they pass in a reference to a const string, and then they pass in a predicate. And that predicate will literally just be a function like that, because that is a function that takes in a reference to a const character, and it returns a Boolean. And this particular filter, if you give it a big fat string like, Hayden, it will only return true on the A because all it's doing is checking if the character's A. So that a string view on the string Hayden with that predicate or filter, predicate's a really scary name for function, right? It will only return true there. And that comes up in a few other functions because that predicate's stored so that when someone, for instance, and this is kind of where the iterator gets interesting, because as you can imagine, if you have this imagine you have a big sentence, as a string, and someone gives a predicate or a function that hates vowels a lot and filters out all the vowels, when someone iterates through that, through your string view, which is just pointing to that string, it'll just print out that entire sentence without any vowels in it, So the predicate's just this little filter that's like tacked onto the string view. Now, that's the high level of it. I could talk about it for an hour and we could unpack everything, but I feel like for it being due in 3.5 weeks, this is a nice starting point to at least make you be like, okay, that I get it enough to start, and then we can always just keep unpacking it more in week 5 and week 7, because we still got 4 more lectures till it's due as well. So, and it's not too hard. What I'd say with this though is that you're gonna again mostly be fighting what to do next. Like you think about word ladder, I know I've said this like 10 times. Word ladder was like, I know like what I have to do, I'm just not sure like the fastest way to do it or how to like the algorithm. This one's like you just got to write the code, but you're going to be sitting there being like, I know this is like a 2-line function, but I'm not exactly sure what the 2 lines should be yet, you know. But use tests to your advantage as well. Usually what I find works with these kinds of class assignments, go define the constructor and then go define the at or the subscript, because once you have the constructor and the subscript, you can write a test. You know, you can construct with like a string that's like Hayden, and then you can test if all the characters are what you expect or something like that, you know. Like do the most essential to get a test passing, because the cool thing about this assignment, which is again very different from word ladder, is if you can get a couple of tests passing, you can start to build up momentum and be like, okay, now I'm going to go and try and do this function today and this function tonight and pass another test, and like just build up that bank of confidence, you know, as you do stuff. Are there any questions on this? Oh, there's a question from earlier. Someone says, what is the syntax for writing default and custom predicates? I don't fully understand that question, but I'd say like it's just a lambda. Like lambdas are just shorthands for functions. So a predicate's just a lambda. You can test out lambdas like I mentioned. There's ones that filter out 9, 0, and space. You could do ones that filter out vowels. I like that one because it's pretty versatile. It's pretty easy to test with. Getting rid of spaces is also pretty good. Getting rid of capitals, it could be anything. Predicate's just a function that takes in a char, returns true, false, one of the two, Boolean. That's what it is. So yeah, any other questions? Yes? Correct, because yeah, exactly. When I was doing the pipelines, I thought about that, and it's like, you should be able to write code that compiles fine and doesn't run correctly. Yeah, so don't hesitate to push up tests that don't pass. Just builds. Just runs make, that's all it does. It's pretty simple. I probably wouldn't recommend for most of you that you write, I know like we get all like TDD in uni and yeah, like, you know, write your tests before you code. I think that's a real hard thing to do when you don't know what the hell you're doing, if that makes sense. Like if I was you and I was writing tests for this, I'd be like, these tests might make no sense. So I would only write like if I were you, I would like construct, do a subscript, create a main file if you're feeling comfortable, run the code, be like, oh, it runs, it gets what I expect, then write a test for it, get that test passing, you'll feel real good about yourself, and then keep writing more tests like that. But of course, you can do it whichever way you feel comfortable too as well. How often an iterator is written? Not that often. But a lot of stuff's like that at uni. You know, we're trying to poke the science of things. Because there's a lot of people out there that might have learned C++ on Coursera or General Assembly in like 6 months, and the only difference between you and them will be like when things get really hairy, you just understand a lot more about what's going on behind the scenes, if that makes sense. It's a little bit like in like front-end land. There's a lot of people working in front-end now that just like went and learned React or Angular on like a website, and they can go make pages for Canva and stuff, and there's some who do. But it's when something gets quite difficult or they're struggling to debug a problem, it's always the people, speaking generally, it's the people that have like 4-year comp sci degrees that typically are able to kind of wiggle their way through the problem a bit more. So I see these things not just as like a cool exercise in, you know, doing something you might do in the future, but also like because you will be thinking about the mechanics of all of this, it'll just make you a far better programmer in anything that's remotely non-standard. Yeah. You're all edging to go. Let's wrap up. Okay. Thank you for coming. And hopefully that was interesting. We'll talk about assignment 2 more as time goes on.